Hello, everyone. Welcome to day 8, factoring difference of squares. So first, what I would like you to do is I would like you to do x minus 6 times x plus 6. I would like you to pause, and I would like you to do this multiplication problem. So if you remember, when we have the same thing but separated by a plus and a minus, you can just square both. Or we can do our double distribute. So x times x is x squared. X times 6 is 6x. Then negative 6 times x is negative 6x. And negative 6 times negative 6 is negative 36. 6x and negative 6x cancel out. So we have x squared minus 36. So when we look at x squared minus 36, you'll notice that it's two perfect squares that I'm subtracting. That is the difference of two squares. So factoring the differences of squares, the binomial expression a squared minus b squared is called the difference of two squares. The following pattern shows how. So if we have a squared minus b squared, we know that it has to be the square root of a squared minus the square root of b squared times the square root of a squared plus the square root of b squared. So when we're factoring a binomial, there's only two things you can do: GCF and the difference of two squares, or dots. So when we look at n squared minus 64, there is no GCF. N squared is a perfect square, 64 is a perfect square, and I'm subtracting. So that means it's n plus 8 times n minus 8, because square root of 64 equals 8. When I look at our second example, there is a GCF in 50 and 72. It is 2. So that becomes 2 times 25 a squared minus 36. Now when we look, we have a perfect square, 25a squared, and 36, and we're subtracting. So the 2 stays out in front, so the square root of 25a squared is 5a, plus square root of 36 is 6, parentheses 5a minus 6. So now let's have you pause and try 1 through 3 and come back and check. So x squared is a perfect square, 81 is a perfect square. So that's x plus 9 times x minus 9. Number 2, m squared is a perfect square, 100 is a perfect square, and I'm subtracting. So that's m plus 10 and minus 10. My Chromebook's being a little weird. 16n squared is a perfect square, minus, so I'm subtracting, 25 is a perfect square. So that's 4n plus 5 times 4n minus 5. So again, pause and do 4 through 7. Okay, so here 4 is 6x minus 10y times 6x plus 10y. 5 is 7x minus 6 times 7x plus 6. 6 is 4a plus 3b times 4a minus 3b. 7 is 15b minus a times 15b plus a. Number 8, we should always look for a GCF first. So there's a GCF there of 2. So it's 2 times 36p squared minus 25. Now we have our difference of two squares. So that's 2 6p plus 5 times 6p minus 5. Number 9, we have a GCF of 2, and notice that it's not subtracting, but this is minus. So first thing I'm going to do is I'm going to flip it. So it's 2x squared minus 2. Then I do a GCF of 2. So that's x squared minus 1 Remember, 1 is a perfect square, so that's 2x plus 1, x minus 1. So I want you to pause and do the last 6. Come back and check. Okay, so number 10, there's a GCF of 4x. So that gives me 4x times x squared minus 25. S squared minus 25 is difference of two squares. So that's 4x times x plus 5 times x minus 5. 11, there's a GCF of 2y squared. So that becomes 2y squared times y squared minus 16. That y squared minus 16 is difference of two squares. So that's y squared times y plus 4 times y minus 4. 12, there's a GCF of 8m, so it becomes 8m times m squared minus 16. M squared minus 16 is difference of two squares, so that's 8m times m plus 4 times m minus 4. 13, there's a GCF of x, so it's 169x squared minus 1. That's difference of two squares, so that's x times 13x plus 1, 13x minus 1. 14, x to the fourth is x squared squared, so that's a perfect square, so that's x squared plus 4 times x squared minus 4. X squared minus 4 is still the difference of two squares, so I factor that again, which gives me x squared plus 4 times x plus 2 times x minus 2. And 15 we'll go over tomorrow in class. If you have any questions, please ask me tomorrow in class.